guys are all doing well, by the way. This is just so strange. I keep waiting for everything to like, oh, it's a weird dream and we're going back to school and blah, whatever. Which, you know, I don't miss going into the building, but I miss seeing you. And it's kind of sad. I wonder what's going to happen in September. But I'm ahead of myself. Anyway, so here's the story. Once upon a time, I had things that were multiplied. The exponents, you guys correctly added them. If you've got two bases that are the same, you add the exponents. Two bases that are the same that are divided, you subtract the exponents. If I've got a base raised to a power, that exponent gets shared, so it gets multiplied by this exponent, and then 2 to the negative fourth is just 2 to the negative fourth, which is 1 over 16. So we're going to talk about exponential and logarithmic equations, which demand that you are able to expand things, but they're logarithms this time. And logarithms are exponents. So when we are coming up with properties for logarithms, they are exponents. You're going to want to have, incidentally, your calculator with you. There's a little bit of calculator stuff, and paper, obviously, to write on. So once you have that with you, just raise your hand. I want to give you a second so that I'm not waiting right in the middle. Okay, awesome. And one other thing I'm going to do is I am going to shoot out the notes. They're going to appear on your screen. You're welcome to save them somewhere if you want, just so you have them up front. I will upload them to Blackboard later, but let me do that right now, just so you have them. So they're going to appear. It'll say, do you want to save it, download it, or you can X out. It doesn't matter. So, but just so that you have it in case the screen goes away or something weird happens. So, you're going to get two different things as soon as I can find them, I think. A little bit tricky. Let's see. Okay, you know what, maybe I'll skip that because that's going to take a little bit of time, and I don't want to take time. Today is really packed, because it's a review from Algebra 2 of logarithms, which then we're going to use to solve equations. So this will be on Blackboard, but you guys have paper. That's a good thing. Okay. So properties of logarithms. Well, we just got through saying, remember, logarithms are exponents, and exponents where the bases are multiplied. What did we do with multiplied bases? So I'm talking about stuff like this. When you multiplied the base, and you can scream it out, shout it out, what did you do to the exponents? Good. Now, when you divided the same base, what did you do? Scream it out. Beautiful. And then when I multiplied a base to a power, what was happening with these exponents? Nice. All of those rules apply. So for this one, and I just covered stuff up so it wasn't overwhelming. So log base A of u times v is log base A of u plus log base A of v. Not real wild about the fact that u and v are on here, but that's okay. Just like we did on the previous page, log base A of u over v. So I'm dividing. Dividing goes with subtraction. Notice I'm writing that log base each time. It makes a difference. You may have a log base 5, log base 2. Okay. Let's find another one. And then this was the last one. This is a little bit weird looking in this format, but because this is an exponent raised to a power, we pull that power into the front. And I know you've seen this before. It's just a nice review. So n times log base A of u. You can have the parentheses or not. It doesn't matter. The ones that I covered up above are kind of weird. Well, actually, we've already done them, so I didn't want to advertise them yet again. And then this one, I guess, if you want to, this is a version of that one, right? So 1 over n. Well, this is the same. I'll do 2 steps for this. It's log base A of n to the negative 1, which just becomes negative log base A of n. So the power, which came because I took something over n and I rewrote it as a power, then that power can jump out front. Okay? Stop me if I'm going too fast. Please stop me. I know you've seen this before, so I'm not spending a ton of time on this. Actually, you've seen all of this before. It's just something that you're going to need definitely next year. Okay. The same rules apply to natural logs. So ln, we said the same exact thing. What is the base for a natural log? Yay. So these guys work the same way. I'll write them out, but it winds up being exactly the same thing. So this is ln u and ln v added. This is the natural log of u minus the natural log of v. This is n times ln u. And this is, just like the previous one, ln. It was n to the negative 1. And that's the same as negative 1 ln n. And the ones that are hiding up here, they're not mysterious. You already know them. So what I'd like you to do, oh dear, there are lots of them. We talked about this before. So if I have the bases that are the same, I've got A and a base up to here. Whoop, that looks all funky, but this is just M. I have a base, and the base is also the same. The bases match. We talked about that last time. That's M. And then under here is analogous using E. And this is really nice. When you solve equations, particularly because we focus from now on mostly on E, despite the fact that you've learned how to come up with these using bases that are not E or using plain old logs. So those rules apply. So raise your hand if you get where we are before we move on. Just raise your hand. Eli and Lauren, you guys here? Just making sure that you are good in the hood. Just raise your hand. You there, Eli? Awesome. Beautiful. Okay, I'm going to skip the examples under there because they're so simple. They're so simple, they're hard. And we're going to talk about this. So notice now I've got bases that are different. I've got log base, well, not different, but I have these guys. And these are a little more complicated, and now I've got x's and square roots and things like that. So the first thing that you do is you take care of the fact that those are multiplied. So I'm going to rewrite this as log base 4 of x plus log base 4 of, and I'm going to write this as x squared plus 1 to the 1/2. So you guys know that the square root is the same as something to the 1/2 power. There is one more thing that I can do. One more thing that I can do. Sarah, do you see one more thing that I can do with this? Because we're expanding as much as we possibly can. And Sarah, you can just grab your mic. You don't have to, but you can text her. Gorgeous. So she says, grab the 1/2, stick it out finally, go home. It's almost Friday. Isn't that exciting? So that log base 4 of x. I miss saying that too. Hey man, it's almost Friday. Oh no, always my poor cats are so confused. They used to know, hey, when she comes home, it's time to eat. Well, now it's always time to eat because I'm always going to the kitchen because I'm always eating. That's terrible. All right. Only difference between B and A is I've got ln. Well, not the only difference. I mean, clearly, there's a different difference. Remember, ln, if that bugs you, you can just write log base e of whatever. Okay. So let's pull this one apart. Division means subtraction. So this is ln x squared minus ln x minus 4 to the third. Question, yes. Or maybe that was just a hit it by accident. Carson, are you doing okay? Because your mic is looking like you're trying to set it up. And usually if you're in setup mode, then you're kind of frozen. You can't hear anything. I mean, you can't do anything. Just check it in with you. Are you there, Carson? Just want to make sure you're doing okay. Okay, well, I'll check back with her. But in the meantime, there's one more thing that I can do. One more thing that I can do. Austin, what is one more thing that I can do? We're almost there. Grab your mic. Just turn on your talk button. Right, just move the exponents to the front. Bam, so I've got 2 ln x minus 3 ln x minus 4. Now I want to ask you a question about this. Hey man, that's subtracted. Can I write 3 ln x minus 3 ln 4? I want you to vote. Give me a check mark if you think that that's cool, or an X mark if you don't. And you're not going to see anybody else's check or X, just so you know. So my question again is, can I break this up? Can I say 3 ln x minus 3 ln 4? Is it legal or illegal? Check or X? Can I do that? So let me write it out one more time. Can I write for this 3 ln x minus 3 ln 4? Yes or no? Check or X? Ice cream or liver? Just waiting for you guys to weigh in. So grab your little check or X button. As I said, you're not going to see anybody else's. Those are hidden from you because I want to know what you think. Remember, it's not a bad thing to be wrong. So if you had thought it was okay, that's fine, because we're going to untangle it. Or if you think it's not okay, then that's fine too. So don't be afraid to weigh in. So Min, let's see, Minthung, just waiting for you guys. Eli, Jeff, Katie, Lauren, who else am I waiting for? Tyler. We're weighing in. I'm saying, is this okay? Forget about the 2 ln x. I'm saying, is it all right to say, oh, those are subtracted, so I can subtract this thing? Yes or no? So you're just okay, so let me publish responses. Oh dear. Oh, something else is going on. So 56% of you said no, and 56% of you are correct. You cannot do this. So that is a big N-O-O-O-O-O. Don't do that. So notice, and Tyler, you had a good observation. So it kind of looks like the same thing. Well, here, what is inside the logarithm, we call that the argument, that is added. But that is not the same as this. So we broke this apart because it's multiplied, so we took the x and the square root apart. But then once you have that inside the argument, you can't mess with that. You can't break that up. So it's a big, gigantic N-O. Cannot do that. So your final answer is this. That's it. Okay. Number 7 is kind of complicated. Right? I've got adding and subtracting, multiplying and dividing potentially. So we can do this in a couple of steps, or you can do it in one giant step, or we're going to do it in a couple of steps. So you notice that I've got multiply on the top and divide. Right? I've got two things multiplied, and I have division. So the first thing I'm going to do is expand all of that. Remember, multiply means add, and then divide means subtract. So let's look at that. That's going to be log base 7 of x plus, I'm going to call this log base 7 of x squared plus 4. No, I'm so glad you said that, Andy. This is supposed to be a cube root. It looks like a cube, and it's unfortunate. That's supposed to be a cube root. So glad you said that. Every year we're like, what is that? Because it kind of looks like that. But this is log base 7 of blah to the 1/3 minus, notice I keep putting that base 7 in there. That's important. And then this is x minus 5 to the 3rd. And then we got one more thing to do. Fong, what is the last thing to do with this one? Got only one more type of operation we can do. Right, move the exponents. 1/3 comes here, 3 goes there. So that would be my last step. So log base 7 of x, 1/3 log base 7 of thing, minus 3 log base 7 of thing. We don't take the thing. Is that a question? Che, what's up?
Yeah, question. Wouldn't you use parentheses around log base 7x, 1/3 log base 7x, x squared plus 4, like that type of thing? Because it's subtraction.
Let me think. No, you do not. So if you had done it step by, it's a great question. If you had done it step by step and you had this and then this, it would still result in the same thing, because then you would still have adding, and then subtracting. So this does not impact the bottom. If you want to do it in a couple of steps, you can say log base 7 of this thing, so just keep the x and the cube root together, minus log base 7 of x minus 5 cubed. So then that minus is here, but then the plus applies to this. Does that make sense? Does that make sense? But if you want to do it in a couple of steps, I used to do this like step by step to the point where I was like on 5 more pages, and you don't really need to do that. So what's underneath gets a negative. Now, if the underneath thing were also added, then it would be appropriate to do one extra step. All right, what I want you to do is give me the final answer for this one. It's going to be spread into 4 different terms. So just the final answer. Text it in, but don't hit send. This guy, you're breaking it up. When you're all done, you should have 4 different terms. I'm just waiting for everybody's text box to be lit up. I'm so sorry. I didn't realize that. Grr, no wonder. I was like, wait, what happened? I flipped pages and didn't realize. I'm so sorry. Okay, so you're on this one. And then I changed the page. So funny. So Eli, just waiting for you. Jeff, Anish. I don't want to rush you. But if you went away, you said, dude, I'm going to log in and run away, I will log you out. So I just want to make sure that you're really here and you're really paying attention. Because I shall call on you at weird times. Eli! I'll give him one more chance. See here? Uh-oh, Peter Choi. Tyler, I just want these expanded out. Oh, sorry. Okay. Shoot out your answers. I am so sorry. I'm pointing around, talking to my cat. Okay, so what I was saying is this negative is down here. Notice this negative because ln 7x minus ln 4y is secretly ln 7 plus ln x. And if you want to put parentheses around them, sometimes that's a little bit helpful too. Let me see if that will make it a little bit easier to look at. So ln 7 minus ln 7x minus ln 4y. Then you break up the ln 7x, break up the ln 4y. So this is broken here. And then the second one, maybe I'll use just a different color. It's kind of squishy. It's okay. Squishy is good. And then this guy, what I'm putting in purple, goes with this. Does everybody understand what's going on? So it's this whole thing that's being subtracted. So when you add inside the parentheses, the negative actually does distribute. So give me a little emotion, a little happy, confused, something, clapping, anything, or anything that you want to. I want to make sure you're all with me. seeing any confused and or throw-up faces, which is a good thing. Okay. All right, so if I can expand them, I can also condense them. So let me get rid of this and this for right now so it's not confusing. So notice you can go backwards. This 1/2 is secretly x to the 1/2. This 3 is secretly parentheses to the third. So I'm going to do that first, and it pays to do this in steps. So if I do log base 6 of x to the 1/2 minus log base 6 of x plus 1 cubed, if you want to condense that one more time, you could say log base 6 of the square root of x. And then the other one just stays the same. Log base 6 of things cubed. And then the last thing that you do is say, oh, whoa, those are subtracted. I'm pretty sure I can divide. Notice you're dividing the arguments, and I'll show you what I'm talking about in just a second. So this is log base 6 of root x over x plus 1 cubed. All of that is the argument. Okay, and by argument, I mean just the thing inside the log. So only that's divided. The square root of x and the thing to the third, that's what's being divided. This is not the entire log. So the first thing I did is I took the 1/2 and I popped it back up, and the 3 and I popped it back up as exponents. I interpreted the 1/2 power as a square root. And then because the logs have the same base and they are subtracted, that means the arguments are divided. And I want to make triple clear that you understand what I'm talking about, because here's the most common error. People will say, oh, well, that's the same as log base 6 of square root of x over log base 6 of thing cubed. So ugly. Okay, this is not true. Not true. Ooh. Do you guys understand the difference between those two? The vast difference. Huge difference. I'm not dividing the entire log by the entire log. I'm only dividing the arguments. No, they would not, Nikki. No, they actually would not. The logs are not going to cancel. You can't cancel this. That's like saying this. I'm so glad you said that, because a lot of people think that. That's like saying sine. Oh, dude. That's like saying sine pi over 6 over sine x, and you cancel the signs. You say, oh, that's pi over 6 over x. Right? You can't just cancel the sign. The sign's doing something to it. Does everybody understand her question? It's hugely important. So it's hugely important that you understand it's the arguments that are divided. It's not the logs. This is not what you're doing. And Nikki's question was fantastic too. There's lots of people that say, oh, the log base 6 and that are going to cancel. I'm just going to have this. And that's not true. And I can show you with the sign, because you would tell me, oh, sine pi over 6 over sine x. You can't do this. You can't just cross out the signs. The signs are doing things. Okay? All right. I'm going to take that as a yes, Miss Rubin. We understand rubber band. Let me see if oh shoot, I wonder, oh, good. I didn't make that. I tried not to make these things that I couldn't pull onto a new page. Okay, so that was the first one. I am going to cover that one up. Here comes another one. We're condensing this. I've got things that are added, divided, subtracted. Anything that follows a negative is going to go on the bottom. Anything that's added And we're going to have an x and a 9 and a thing and a 5 and a y. So we can do this in one giant step if you realize that it's the sign in front that's impacting it. If this doesn't make sense to you, please let me know. Please, please, please. Because I understand you've seen it before. So I'm not teaching this as though you've never seen it. So this is going to be ln 9x times x squared plus 6 all over 5y. So you can jump directly from the expanded version to the condensed version. You've got things that are added, so this must be x times 9 times parentheses. That goes in the top. Anything that follows a subtraction sign goes in the bottom. And notice I'm only picking the arguments. I'm only picking the thing in back of the ln. The ln itself stays on the outside. So let that marinate in your head. See about this one. So here I've got a power that can be restored. This, oh wait, dude, we just did that. I'm so sorry. It's because I copied the page. Okay. But what I didn't do, because that other one's on the other page. Okay. I want you to try this one. You want to squish it as much as you possibly can. Squish. And if you, yeah, try it on a piece of paper. You can text it in. It's a little bit tricky to text in. You need a billion parentheses for this. Just text it in. So Minfa, still waiting for you, Jane. As soon as you are ready to roll. All right, shoot out your answer. Very nice. Beautiful. Gorgeous. Okay. Very nice. And when you're doing these, so some of you were missing parentheses. Now, you wouldn't have this problem if you were writing it. But some of you left out parentheses, like, okay, so maybe you did this, 3x plus 5 over 4, x minus 1. When you're typing, oh, wait, ln x, so I didn't mean 4, I meant x to the 4th. So, x to the 4th and that. When you're actually typing it in, you're going to want to, that's what I was saying, you got to have a million parentheses. So you know that all of this is the argument for natural log. Okay, beautiful. Okay, sometimes your calculator is your friend. We used to teach something, and you still see it in books, the change of base formula, because when I was a young child, there was no such thing as a graphing calculator that could do anything kind of near this. So if you had a base that was a weirdo base, then if you wanted to figure it out, like log base 2 of 14, I don't know what that is. 2 to some power equals 14? Who knows? So I could have written log of 2 over log of 14, or ln 2 over ln 14 and stuck that in a calculator. But you guys have a log base button. And I want to make sure that you are good. Jeff, are you okay? We already sent those and your text box is still lit, so I don't know if you sent it. Jeff. I'll leave that because maybe he'll do that. All right. Do you guys know where the log button is? The log base. I don't know if you do. I must locate my calculator. Because I cleaned my room. And the problem with that is that I can't find it. What were you typing? I was asking you about the previous question, and then you didn't answer, so that's why. Okay. I do have a calculator. It's just on. So, let's see. So you can do lots of ways for this. You can do second. I'm just kidding. Alpha. Oh, that's so ugly. Alpha. F1. And then scroll over where it says log base. You can also do alpha F2, which will give you the same thing. This is so hard to write. Okay, so for this one, if I do log base, just to make sure that you know how to do this. So log base 2 of 14, I'm getting 3.807. And just be aware you want to go out to 3 decimal places. Remember, that means if I were to set 2 to the 3.807, so don't forget what this means, 807. Then that should equal 14 approximately. It's not going to be exactly. I want you to think about why. Yes, you can also use math A. Math A. I see. You just don't see it. Yeah, that's like the other one. So lots of ways that you can do this. You want to be good at doing this. I want you to raise, so that's your actual answer. That means that 2 to the 3.087. So if I actually do that, 2 to the 3.087. Now I'm going to have a problem with this. Let me just, I messed it up. So when I actually do this, so in my calculator, if I wanted to check this, and I actually raise that to that power, so I would get 8.497. And that's not, whoa, 3 point, hang on. I think I must have done something really weird, because that's not going to work. Okay. Try this again. Log base 2 of 14. So 2 to the answer. Oh, I see. I see what I did. I transpose the numbers. Okay, so if I actually do that, yeah, exactly. That's see, I transposed them. That's just it. You see how crazy that is? It's kind of scary. Okay, yeah, 0.807. When I actually do that in a calculator exactly as it looks, it gives me 13.9965, blah, blah, blah. Why is it doing that? It's not giving me the answer that I want. J2, I think you answered it so quickly, I almost missed it. Libby, are you there? Your text box is lit up, so it looks like you're about to ask a question. Oh. Okay, so does everybody understand what's going on? This is a rounded value, so you're not going to get 14 exactly. No, that's fine, Libby. I was just making sure. So same thing with this one. So you're going to do log base 3 of root 5. I want an answer for this one to 3 decimal places and an answer to that one. Just type them in and then wait. Type and wait. So to 3 decimal places. I just want those answers, but then wait and send again. Okay, shout it out. Beautiful. Awesome. So you can just hit send, just making sure everybody hits send. Andy, you okay? Ah, yay. Okay, so now we're going to put these to use. So the rules of logarithms, and when we're doing these, there are 2 different ways that we're going to do them. The first way is, if you can, so this is an exponential equation. Eventually we're going to solve them with logs also. So the question, hey, we did this. I just realized we did this last class, didn't we? We changed the bases. We said this is 3 to the 2x equals, am I just completely wrong? 3 cubed. Did we do that? I am losing my mind. Did we actually, am I just dreaming? Did we do that? Oh, thank God. Oh, that's a beautiful thing. Okay, that's what I thought. All of a sudden I was doing it, I'm like, wait, these notes are weird. Okay, this we did not do. I'm so glad we did that. Okay, if I have e to the x plus 5 equals 60, now I'm trying to solve it for x. This we didn't do because there was no way to rewrite e because it's a irrational number. But I'm going to solve it like a regular equation, and for all of these, if I need to solve for the exponent, I'm going to use the natural log. And I know you guys have learned it a couple of different ways, but as a nod to higher math, which is where most of you are going, we're going to keep with what you are going to see from now on. So, by that I mean, just like any equation, just ignore the e to the x, who cares? This is going to be e to the x equals 55. Now, to get myself out of that, I am going to take the natural log of both sides. So, and I'll rewrite it in a different line. I'll say ln e to the x equals ln 55. Now, the advantage to that is on the left side, remember this base is e, right? I've got log base e of e to the x, and that has the effect of canceling, which is beautiful. So this is gone. I just get x equals ln 55. Done. I simplify that. I don't even mean simplify. You can't. I would not give that in 3 decimals unless you absolutely have to, unless you're asked to. ln 55 is a beautiful number. It means e to the ln 55 is going to give you 60. Okay, so it works just like anything else. We did that kind before. So let me come back. Okay. We have not done that kind, I don't believe. I'll get rid of the one underneath. Sometimes it's confusing if you see too much stuff. Come back. Come back, come back. I tried to cover you up, and it did not work. All right. So you got to be kind of sneaky smart and remember all the rules. So remember the rules of exponents that we did way, way early on? If I've got the same basis, what is happening with the exponents? I have a base to an exponent times a base to an exponent. Exactly. The exponents are being added. Excellent, excellent. So I'm going to rewrite this as e to the 4x plus x squared equals e to the 12. Well, what can you do? My bases are the same. What would be fun? What would be a fun thing to do? So I want people to weigh in. Nikki, I see what you're saying. I just want to make sure everybody has a chance to think about this. This is similar to the ones that you guys did. If I've got a base to a power and a base to a power, these powers don't have a choice. They have to be. If this is true, then the powers have to be equal. So the only difference between this and the stuff that you did before is we've got a weird base. And the exponents are going to create a quadratic. So I'm going to do the rest of this up here. I'm going to say 4x plus x squared equals 12. Now you're in baby math. You're in algebra 1 math. I'm going to move the 12 and just reorganize this. And it's simplified. So I'll have plus 6 minus 2, and I'll get 2 answers, negative 6 and 2. When they are exponential like this, you don't have to check the solutions. When we solve the logarithmic ones, which we're going to do in just a minute, you will need to check solutions. But here, things to powers, there's not going to be anything that's not okay for this. So your 2 answers for this, x equals 6, negative 6, and x equals 2. 1. Okay, so I feel like I'm going at lightning speed. So I just want you to give me a check mark if you are okay, if you're up to speed, you see what we're doing, you're ready to go. I don't want to go so fast that everybody's just scrambling and they give up and go on, I don't know, Twitter or something. Okay, so I'm just waiting for check marks. Amanda, I'm not trying to rush you. I just want to make sure that you're ready to move on. Anish, Carson, Darby, Lydia, Lauren. So just a check mark. If you're good with where we are, you're caught up. I'm not going so fast that you have no idea what's happening. Minton, are you there? Did you go run around the block and buy us all tacos? Oh, darn. Okay, Very nice. All right, just a couple more examples. So, and this one, oh, this is a straight up factoring one. But it's not, well, okay, we can do this. I'm trying to get to the equation part. This is an equation part, but it's not equations with logarithms. And some people would say, I don't know, what the heck am I going to do with that? How do I do this? What would you do? Any ideas? I'm trying to solve that. I can't take the natural log of both sides. There's no way to do that. I want you to compare this to, what if I had x squared plus 6x minus 16? Would you know how to solve that? What would you do? This is just an analogous equation. That's not what we're solving. But how would you go about that? I don't need to know the answer. I just want to know the what if. What would you do for that? I mean, you can solve it many ways, but what could you do? Are you stuck like a truck? What can I do to solve that green thing? Totally, exactly. You in fact, this is totally different. Not really, but it's totally different question. I'm not asking you about this one. I'm asking you about an analogous question. So if I just gave this to you in Algebra 1, you could say, oh, I know what that is. The factors are, it's going to be 8 and 2 and plus and minus, blah, blah. Well, this is the same thing. The only difference is my base is E. Don't be alarmed. Bases of E are your friends. I could say this is the same as E to the X. E to the X. This is going to be plus 8 minus 2 equals 0. The same way that if I had done this one, this would be X plus 8, X minus 2 equals 0. And if you're not sure, if you do it and you go, I don't know, I think that's right, just FOIL it. So e to the x times another e to the x is going to give you e to the 2x. Negative 2 times e to the x plus 8 times e to the x, negative 2 plus 8 is really 6. And then the 16 got broken into 8 and 2. So it's analogous to this. We call that quadratic form because you have powers that are double in the beginning. So this power, just like up here, this power in the quadratic is double the x. So this has a power of 2, this has a power of 1. This has a power of 2, this has a power of 1. And then you would go ahead and solve it the same. Now here's the deal. If I have e to the x plus 8 equals 0, that means e to the x equals negative 8. Now this is an interesting thing. And then this will be e to the x. So notice we're doing the same thing, equals 2. When I take the natural log, and I get ln e to the x equals ln negative 8, I can stop right there for that part. Why can I stop? What is wrong with this? Yeah. This cannot be negative. Remember we made a big deal out of that last time? This can't be negative. So for this side, there's no solution. This side will give me a solution. But I can stop right here. That cannot be negative. But this one is fine. ln e to the x equals ln 2. That means, and those have the effect of canceling, x equals the natural log of 2. Yes? bad? Ice cream liver? Can you go to the x equals negative ln h here to keep this ln to the x? Well, you can't do x equals ln negative 8. That's the whole point. You can't say x is equal to, I mean, obviously, yes, you could write this, ln negative 8, but then you would say no solution for that. You would say that thing does not work. There is no natural log of negative 8. You see what I'm saying? So yeah, you could continue on, but what I did is I just stopped. The minute I saw this negative 8, I said, nope, ain't happening. Okay. For example 10, bases are different. I can't write this as 5 to a something and 5 to a something. The bases are totally different. So the question is, what in the world do you do? Well, here's what I would do. I would say, I don't care if the bases are different. I'm going to take the natural log of both sides. Oh, would that be? Yeah. Okay, I'm going to take the natural log of both sides. This is going to connect back to the very beginning of today. Notice I've got a log raised to a power and another log raised to a power. What can I do? What can I do? If I've got a log raised to a power, what can I do with the powers? Right, you can move them in front. So here, and I'm going to get rid of this because this is difficult for me to look at all of this and do the same problem. Okay. So I'm going to move those to the front. I'm going to say, all right, well, that's the same as x minus 2. I was taking that log and then I got rid of it. ln 5 equals 3x plus 2 ln 3. It's great fun. Now remember, ln 5 is just some number. I don't know what it is. It's just some random number. This is just a number. That is just a number. I'm trying to get x's on one side. So here's what I'm going to do. I'm going to say, well, so how about I just distribute the number through? ln 5 is just some, I don't know, positive something or other. Same with ln 3. So I'm going to distribute that. It'll look ugly, but that's only if you don't recognize, hey, wait, ln 5 is just a number. So I have ln 5 times x minus 2 ln 5 equals 3 ln 3 x plus 2 ln 3. Does everybody see what's going on with this? So the first thing I did is I took the natural log of both sides, I moved the exponents, and this is just some wacky number. Think of it as pi. Pi times x and pi times 2. Same idea. It's just a weird number. I don't know what it is, but I'm going to distribute it. It becomes the coefficient of x, and it just gets multiplied by 2. Here it becomes the coefficient of x again, so this is a number. And then I'm going to move all of the x's to one side, all of the numbers to the other side. So I'm going to take this, and I'm going to move it over to the other side. Okay. So this becomes, and I'm doing extra steps. Like we could have done this a whole lot faster, but I don't want to lose you in the process just because it looks so weird. I'm trying to use those parentheses so you realize those are just numbers. I'm going to move the 2 ln 3 and the 2 ln 5 to the other side. So 2 ln 3, 2 ln 5. I'm going to factor out the x's. So, just like typically you would. So now I have ln 5 minus 3 ln ln3. Here's where you gotta be persistent in math. You just have to make sure you got enough sleep, and then suspend your discomfort. Okay, check that out. I am ready to go. I've got an x by itself over here, almost, except that it's it's multiplied by a number. This is just a number. This is like saying 5x equals 12. No different. How am I going to get the x by itself? It's x times this weight, crazy parentheses. Tell me the opposite of multiplying. Nice. So my final answer, exactly. So I am going to do something exciting here. Well, maybe I'll do it right here. I was trying to make sure I had enough room. So x is equal to 2 ln 3, 2 ln 5, all divided by ln 5, 3 ln 3. And you can do all kinds of stuff with that. I would just stop and go home. Oh, wait, you are home. Never mind. Stay home. Socially distanced right there. Okay, so it's a long process if you're showing all the steps. When I'm doing these, I try to do them in my head, and of course I do something silly. So I generally will show myself steps. So let me just recap. We took the natural log of both sides because I couldn't write the bases the same. I moved the exponents down. I distributed the two weird numbers. Got my x's on one side, and then divided. Done. Okay. Give me a check mark. I want to know before you go if you're good in the hood. Okay, so Case, just want to hear from you, and Darby, Kimberly. Maybe you're in a different class. I'm so sorry. Some of you are coming in, which is awesome. Okay, so you have an exit ticket. Once you click on it, I'm going to alter the homework. That's why I don't post the homework, because we only have like 45-minute classes, and then we almost go over. So no, Tyler, don't run away. There's an exit ticket. So make sure you do this. It's questions about expanding and condensing logs, and then I've got to alter the homework that I already made because we didn't get to solving equations, and that's fine. There's no worry about that. So click and have a fun day. I'm going to stop the recording.